Hello, deep learners. I'm Andrew Ng, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on the batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so let's you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
Yep, and that's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
Hello guys, can you hear me? Yes, everything is okay, I think so. And good morning to everyone present here. And today's webinar will be covering that concentrating the data science with our neural networks. At first, I would like to thank Grow90 community as well as the deeplearning.ai platform for arranging such a platform that is a forum to work and to educate the students, those who are interested, really interested in learning AI. So this is being a big community. They have been uh, tremendously working in establishing and resourcing the persons. So as a part, I am Vignesh Prabhu Thangavel, senior data analyst and IoT engineer at AB Semiconductor Designs, Chennai. So here to have a deliberate lecture over what is the thing that is happening right now, that is the scenario that is happening, and correlating the data science with the deep learning, that is the neural networks. So this session will be a uh, introductory class to you, that is how far you need to approach the deep learning models as well as your neural net concepts. Followed by that, you will be having the coding part, that is how you need to code your models, mathematical models, and how you need to have your applications to be selected and to work in it. So this will be our common agenda. So let me proceed with the agenda, that is so at first half we will be covering what is deep learning and introduction to deep learning and neural networks. Followed by that, what is the coding part that we need to make and the software packages which we are going to use. So this will be covered in the second half. On followingly, you will be having a queries and discussion session where you can have your queries and you can have a discussion forum in common, so that you may get clear with your ideas and your doubts to work in this AI platform. So at first I'll be showing a pic that how much impact has been made by this data science and data analytics in the environment, that is in the globe. So every MNCs and every top leading companies have been working with this data science and data analytics, because the data is being the tremendous one in this era, that is the revolution of industry 4.0 5.0 has been made. So it has been a tremendous one. So being developed one, every companies are approaching to the data science part, and they have been working with this algorithms. So this is the exact scenario what is happening in the industries and in the globe. So now let me switch to the next one, that is the next part. So applications of data science. So what are all the applications that we can develop with the help of the data science? So at first let me concentrate on image recognition form, that is image recognition pattern. If you look into this image, uh, basic example is that your face unlock pattern. So this purely made by AI technology, that is AI comes into picture where you are unlocking your mobile phones with the help of your face, that is the image. So the extraction of image as well as the data will be considered in this part. So you will be covering the image recognition concept with the help of your facial recognition or facial action images. Here a notable point is that how your image has been processed. That is your big question that is prevailing in everyone's mind. So I like to answer it in a simple way that if you are taking an image, it will be considered, and your image data will be taken into picture, it will be taken into account. So let me zoom in my slide. Okay, fine. So with the help of this image patterns, you can make your unlock system, as well as you can make your face recognition system. Followed by that, you can make an attendance system or any object detection models such as Coco model, Cafe models, etc. So this is the major application which can be made with the help of this image recognition patterns. So next part is that speech or voice recognition. So in current scenario, we are using the Google Siri as well as iPhone Siri and Google Speak and Alexa and the upcoming technologies in your voice. So how this happens is that your voice model has been made with the help of these AI and ML technologies, where they are developing this voice models with the help of DL architectures. And if you are giving an input, your voice will be taken into consideration, where your voice will be splitted into your samples, and they will be applying the upsampling and downsampling theorems to segregate your samples alone. Followed by that, your samples will be taken as a data. When your input data is given, and your machine will be gets trained with the help of this input data. So followed by that, if we are giving an input, that is for a testing purpose, I am going to open my mobile phone, or I need to speak with my Siri, right? Siri or Google Speak, right? So if I am speaking or communicating with it, it will be accessed, and your phone will respond to it, right? So this purely works on the DL architecture. At present, Google is using WaveNet model as its DL architecture. If you have doubts, you can refer what is called as a WaveNet, right? So WaveNet is nothing but it's an DL architecture which comprises of hidden layers and neurons, which takes your voice as your input. Followed by that, it will be splitting your voice into samples. So your sampling theorem is applied there, and it will be taking your exact voice, that is based on your pitch and frequencies. It will be extracted. Followed by that, it will be taken as a training data. So based on this, your machine gets trained with the help of this data. After that, if you are giving some test data as an input, your machine will respond to it. So next to that, we have gaming applications, that is AR and VR comes into picture, where your game models has been made with the help of this data science applications. So it will be having a number of datas. So these datas will be taken, they will be collected, and it will be used for its further applications, that is the development of the logics behind the games, and the development of the user friendly games. That is, if you are going for an online game, your n number of users will be connected to it, right? So this purely works on the data science application. And next to that, I will be explaining you the main concepts that prevails behind the Flipkart, Amazon and other e-logistics, right? So delivery logistics, we will be calling them, right? So we will be ordering a product in our online, that is online shopping mart or shopping cart. So we will be taking the desired product from the online, where your product will be considered as a data. So your user will be taken as a data, and the user's data will be fed into the machine, so which automatically process and predicts you which area it needs to be delivered. Followed by that, who are all the suppliers or vendors those are available in that particular area. So this will be taken into consideration, where your data science plays a vital role, and your network architecture also has an vital task to be done. So in this area, we'll be concentrating with AIs, right? So this will automatically allocate in which area I need to deliver based on your pin codes, so that your delivery can be made easier. So next to that, you will be having the fraud and risk reduction techniques. That is, if you are going for an security algorithms, you will be considering this term fraud and risk, right? So in AI technologies, we are using this data science that to store the records of a person. Followed by that, your input will be taken and stored as a data. So we will be making an matching algorithms for this. If your input gets matched to is the data that is input, that is fed into your network, you will be getting a desired output, right? So this is the logic, common logic that provides behind this. And next to that, you will be having a price comparison websites, right? If I need to buy a product, at first part I will be checking the price, and I will be comparing the price with the other online carts. So here your data science comes into picture, and you will be taking your data and you will be comparing your product with other online logistic carts, right? So where you will be having your original data, that is your price of your product, in one website, that is in one e-cart. Followed by that, you will be having your same price, that is the same product will be in another market, that is another shopping cart. So you will be comparing those two products as well as the price of it, and you will be buying the best one, that is the cheaper one which is available, right? So this is the logic behind the price comparison websites. Here you will be having a tremendous data in account. So these tremendous data will be taken, they will be comparing it, and they will be having a live comparison tool for you, where you can visualize the data, that is the comparison chart, and you can pick your best product at cheaper price, right? So next to that, we are having some a number of applications like recommended systems, digital advertisements, internet search, AR, VR, that is augmented reality and virtual reality, and the healthcare applications. In the healthcare applications, your data science plays a major role. In this current scenario, due to the COVID, your data science has been increased tremendously in medical aspect. That is the collection of the patient's data, and they have asked for some ML and DL algorithms for it. So we are also working on this platform, and we have also developed some AL and ML algorithms for this COVID-19. I'll be explaining you later what is it actually. So now I'll be moving into the next slide, that is what are all the types of learning. Before working into an DL, that is neural networks, this is the basic fundamental one. We are having four types of learning models actually, that is supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. But majorly we will be covering only the three types of learnings: supervised learning, unsupervised learning, and reinforcement learning. At first I will be explaining what is this learning actually, why we need to have this type of learnings. So if I need to train my machine, I need to have some learning algorithms, right? So whether I need to have it as a supervised learning model, that is if I need to have input and output values, and I need to train my machine, there comes the supervised learning, and it plays a vital role in that. And in the unsupervised learning, you will be having only inputs, and you will be making some clustering algorithms based on it. And in the reinforcement learning, it will be making decisions based on the previous actions. That is, it will be having some past records, and it will be making some actions, right? So in detail, I will be explaining you what is supervised learning actually. In supervised learning, we will be having input data, and you will be known with the output. For example, I can say you that if I go to an hospital, and if I am checking for my body temperature, that is if whether I am having fever or not, so I am checking for the condition, right? In this case, I am having a temperature value, that is my input, and I am going to predict whether I am having a fever or not, right? So this will be my output. So in this case, I am having both inputs and outputs as well. So this is called as supervised learning. In short, I have explained you that what is a supervised learning. So in supervised learning, you will be having your input data, followed by that you will be known with the output, what is likely to occur. So in supervised learning, you are having two types of models, that is classification model and regression model. I will be explaining you what is classification and what is regression. Next to that, you are having an unsupervised learning. What is unsupervised learning? If I am having certain input and I am not sure what will be the output that is likely to occur. So in this case, this is called as unsupervised learning. The best example I can say you that if I am measuring the earthquake with the help of the Richter scale, I will be having the values at present, right? So I can't judge what is the range and what is the basic actually that is likely to occur. So if I have some values at the time, I will be taking, oh, this is my particular condition, I need to mean it, right? So here comes, we are not sure what will be the output that is likely to occur. So we will be going for clustering of your data. That is, we will be grouping your input data. So there comes the unsupervised learning. So the reinforcement learning, the best example is that if I need to train my robot, okay, you can take my robot as my example. I am training my robot. At first instant, I am giving some input to it, and it will be responding as accordingly the input which I have given. So followed by that, it will be responding you one action, right? If you are giving some input, it will be responding you some action. So in the next case, whether I need to respond to the previous input or not, it will make some decisions, right? So reinforcement learning says that it will be tuned based on your previous input, and it will be making your actions faster enough when if you are giving the same input again. Another example is that when we are training a child in the small age, it will be making some mistakes at the small age, right? We usually have this tender opportunity, that is, will be having this tendency to make a mistake at the smaller age. So we will be making some mistakes, and our parents will train us and teach us that we should not make this mistake again if you are doing the if you are stuck into the same situation. So this is the case, and if I struck into the same input, that is the same situation again, I will be cautious enough that I need not to make this mistake again that was taught to me by my parents. So this will be my reinforcement learning. So I will be having an action that whether I need to make a decision for this input or not. So this is the reinforcement learning. So in the next this slide, you can see what is supervised learning, unsupervised learning, and reinforcement learning in text format. So which I have you explain. The one thing I have missed is that labeling of data. So what is labeling of data? If you are working with the data, you will be having some values, right? So those are called as input values and your output values. So input values are called as features in your data science, and output values are called as labels. So if I'm known with the input, that if I'm known with input and output in the supervised learning, I need to label my data. So there comes the labeling of data. Labeling is nothing but you'll be having some groups of outputs, right? For example, take the same case again, that I'm going to a hospital and I'm checking for my fever, that is my body temperature, whether I am having a fever or not, right? So in this case, my fever is one label, and my normal case is another label. That is, if my body temperature is above 98.6 degree Fahrenheit, I will be termed as a fever patient, right? So this is a label, and you can name as such you wish. That is in numbers. We need to have your labels in numbers. That is either as a 0 or 1. So I will be having my label as 1 in this case. That is, if I am having fever, I will be having my label as 1. Or else, if I am a normal patient, that is a normal person, I will be having my label as 0. This is called as labeling. Based on your outputs, you need to label your data. So next part is that unsupervised learning, where you are not sure what will be the output that is likely to occur. So you need not to have your labels of your data. That is, labeling of data is not necessary in this case. So next part is that in supervised learning, there are two types, right? that is classification models and regression models, which I have explained you earlier. So what is classification and what is regression actually? So classification is the thing in which we will be dealing with the discrete values. That is, we will be taking either I am having a fever or not. Let us take this example that is present in a picture. That is, in the classification model, I am going to classify whether my temperature will be hot or cold in tomorrow by tomorrow, right? This is my example. So here I am having my hot or cold condition. That is, both conditions are existing. So this is a classification model. That is, I need to classify whether my temperature will be hot or cold. That is 0 or 1s. So if you are dealing with the booleans or if you are dealing with the labels, that is your classes, you will be having the classification models. So labeling of data, which I have mentioned you earlier, will come in these classification models. So next to that we are having a regression model. So if we are dealing with the continuous values, we will be termed it as a regression model and we will be proceeding with the regression algorithms. So for example, let us take this example case again. What is the temperature going to be tomorrow? That is, I need to have an exact value of what is the temperature that will be by tomorrow. That is likely to occur in tomorrow, right? So if I am being precise with a value, that is, if I am going to predict the exact value that is likely to occur, it is called as a regression model, where you will be dealing with the continuous values, right? So you will be having a regression models. So this is the basic of an AI. That is, if you are working with an algorithm, that is deep learning models or a machine learning model, or if you are into an AI network architectures, you need to have a keen knowledge about what is the type of learning that I am going to make and what is the type of learning that I am going to work with it, right? So next part is that I am sure about what is the type of learning I am going to work with, right? Either I am going to work with supervised learning, unsupervised learning or reinforcement learning. So you can select this type of learning based on your input data. That is, I am going to choose an application, right? So my application will be either I am going to have segregation of normal patient and an abnormal patient, or I am going to have some classification of images, or I am going to predict some object deductions, right? So you are having n number of examples. So in this case, you can have your data set based on your application. So after that, with the help of your data, you can select what kind of learning algorithm that I am going to approach. So this will be your next part. Followed by that, you need to pre-process your data. So your data can contain invalid data or your data can be a raw data or an invalid data. So you need to pre-process your data. So pre-processing step comes into picture. Followed by that, you need to select a deep learning model. That is, if I'm going to work with a neural networks, I need to select my deep learning model. So at first I will be explaining you what is the difference, major difference between a machine learning model and a deep learning model. So if we are working or if we are concentrating with minimum number of data sets, we can go for a machine learning model. That is, we will be having some learning algorithms like SVM, RF, decision trees, etc. So you can have your machine learning models. Or if we are going with large number of data, that is, if I am going to work with an image, I will be having a number of data, right? Large number of data. Or else if I am going to work with an object detection model, or if I am going to predict some forecasting one, that is, I am going to make a stock market prediction or not. If I am having an application in a wider range, I need to go for a neural networks. Okay. So what is neural network actually? Let us see. So in this case, I am having a large number of data, right? So my data set is a greater one. I am having large number of data, so that I am going to concentrate in neural networks. So it can be either your supervised learning models, that is classification or regression, or unsupervised learning. Your learning algorithms can differ. If you are working with a neural network, your learning algorithm can be differed based on your input data, right? So this is the common terms. So now let us see what is a neural network and what are all the parameters that we need to analyze and that we need to stick to while working with a neural network. So now let us see the basic parameters that we need to look into while working with a neural network. That is, you need to at first part you need to concentrate on neurons and activation function. What is a neuron and what is an activation function? Followed by that, you need to concentrate on cost functions. That is, what is the cost function and how to approach with the cost function. Next to that, you are having a gradient descent. I'll be explaining you what is gradient descent and a back propagation. So these are all the parameters that we need to concentrate while working with a neural network, right? So before to that, these are parameters and we need to concentrate on the layers actually. So we are having three types of layers while working with the neural networks. So the first layer is called as an input layer. Next to that, you will be having hidden layer. Followed by that, you will be having output layers. So we are having three types of layers, and in the layers you will be applying those basic neural network parameters. That is your neurons. You will be defining your neurons activation function. Followed by that, you will be having cost function, gradient descent, and back propagations. So I will be explaining what is what actually. Okay, let us concentrate on neurons. So what is a neuron? Now let us look into our biological parameters, that is your body parameters. You are having your brain, and from your brain your signals will be transmitted to your organs. That is, it may be an sudden reaction or it may be an later action, right? So if I am going to touch a thing, that is, if my hand is touched to a fire, I will be getting some immediate responses. So these immediate responses will be taken in your spinal cord reactions. So your actions will be taken and your informations will be transmitted to your hand, that I need to take my hand from the fire. So this that is your information transmission will happen in your neurons. So your body contains millions of neurons, millions and billions of neurons. So what is a neuron actually? So this is a example, that is the image. So you are having dendrites, your body and your axons. So from your body, your information will be received from axons and it will be transmitted to the dendrites. So in the similar fashion, you will be having a number of neurons connected to your dendrites, and followed by that, your information will be transmitted either in an electrical pulse, right? So in the electrical pulse, your information will be transmitted through the neurons, and it will be transmitted, and you will be receiving the information that I need to pick up my hand from a fire. If I am exposed to a fire, right? So this is the thing actually happening inside our human body. The same way, we need to work with the neurons in neural networks. So these are all the most commonly available neural networks, so which we can work, and they are also working with this neural networks, right? So a number of neural network models are available, and in the left hand side we have listed out what are all the cells that are available inside your neurons. That is, if you are concentrating a neural network, you will be having neurons. A number of neurons will form a neural network, right? So in neural network, it will be comprising of cells. So we need to concentrate what is a cells, what are the types of cells that are available, and how to process, and what are all the functions of the cells that can be made, right? So at first part, let us look into the input cells. What is an input cell? In a neural network, if you are giving some inputs, that will be called as input cells. So input layer will comprise of your input cells. And in the output side, that is the output layer, if you are concentrating with outputs, you will be having output cells, right? So this is the case actually. So you can see the top neural network architecture models that are available. So these are the n number of ones, that is starting from the perceptrons. You will be having feed forward network, the radial basic networks, convolution neural networks, deep forward neural networks, and Boltzmann machine, and recurrent neural networks, LSTM, long short term memories. Okay, you will be having a number of neural networks, right? So let us see what is a basic neural network, that is, what is an artificial neuron actually is. So this is the building block of a neural network, right? They'll be calling it as a perceptrons. So these perceptrons make you a neural networks. So what does a perceptron actually contain? Let us concentrate with respect to our inputs and outputs, right? So if we are having multiple inputs, that is I am having two inputs and I am having one input, one output. So if I am concentrating over this model where perceptrons comes into picture. So in this perceptrons, you will be having two inputs and one activation function. This is your activation function. Followed by that, you will be having outputs. So now let us activate and work with this perceptron. So how this neural network actually works, that is how your perceptron actually works, is that I am having some input, right? My input is 0. From my input 0, I am feeding in a value as 2. So this is my output 1, my input 1. From my input 1, I am feeding my value as 4, right? So let us take these two values, that is 12 and 4 will be your values. So you are having some activation functions. Why we are using this activation function is that you need to activate your hidden layers to pass your messages. Similarly, if you are considering your body neurons, your information needs to be passed, right? Then by your neurons gets activated and it will be transmitting your information. The similar fashion, you will be networks a concept named activation function. This activation function helps you in activating your network. That is, your input will be fed, your activation function will get activated and it will be giving you some sort of outputs, right? So in a basic perceptron, your weights will be assigned randomly. What is called as weights? So at first, let us concentrate what is a weight. Similarly, let us take biological neuron as an example. So if I am working with a biological neuron, I need to have some volt or millivolt to activate my neurons so that my information can be passed. So this millivolt, that is the required amount of millivolt, we will be taking it as a threshold one, right? So in similar way, if you are having an activation function, you need to have some values to activate your layers. That is, if I need to pass on my information from input to output, that is, I need to process my informations to predict an output, I need to activate my function. That is, this layer gets to be activated. For this purpose, we need to assign some weights for it to get activated. So thus, your activation function comes into picture and your weights parameter will be assigned to it. So if you are using the weights parameter for a normal perceptron, it will be assigned randomly. In this case, your weights are 0.05 and -1. They are assigned randomly, okay? So that based on your weights, you are getting an output values. That is, from input layer 0, you are getting your value as 6. From the from the input layer 1, you are getting the value as -4, okay? In this case, if your input value is +1, that is after multiplying with your weights, if your input value is a +1, your output will be a 1. If my case is that, what will happen if my sum of the inputs is a -1? So you need to take this case also, right? So if my input is a sum of my input is a -1, my output will return as 0 in the output function, right? In the output layer, I will be getting the value as 0. If my sum of my inputs is negative, if my inputs are positive, I will be getting my value as 1. So this is the case that will be happening in the perceptrons. So what is the activation function that we have used here is a sigmoid function. So in the next slide, we can see what is sigmoid function, how our weights are assigned to it, and how it gets activated. Okay. Okay, now let us see a layer that has been developed with the help of the perceptrons. So if you are having multiple perceptrons, you will be calling it as a neural network. If your multiple layer perceptrons gets increased more than the 3 hidden layers, we will be calling it as a deep networks. Okay, so this is the basic logic, and let us see how this multiple perceptron has been formed. So in this side, you will be having a violet case, that is the violet ones. So these are called as your inputs. So you will be having 2 hidden layers to it, and you can have one output layer. So these hidden layers and your outputs are defined by user, and it is depending upon the type of input that you are giving and what is the type of learning model that you are going to develop. That is, either if I am going for a supervised learning model in classification network, so I need to have either my output as 0 or 1, so I can have one output layers. Or else, if I am going for an unsupervised learning model, I need to cluster my group data, that is, grouping of my data is likely to occur. In this case, I can have number of output layers based on my parameters, that is input data. So this is the definition of your layers, that is, if you are concentrating with input layer, what is called as an input layer. So if you are going with an hidden layers, what is a hidden layer? And if you are going with output layer, what is output layer? So that's what I have explained you earlier. If you are going with the input layers, you will be getting some values from the user, that is, you are feeding some input data to it. Followed by that, you will be having the hidden layers. The number of layers will be increased based on your user perceptions, and you will be having your output layer based on your output, that is, what kind of model you are going to develop, either it's a supervised learning or unsupervised learning, classification or regression. You will be deciding your output layer based on your performance outputs, right? So we have covered what is input layer, what is hidden layer, and what is output layer, right? So hidden layer is nothing but a layer which is intermediate between your input layer and an output layer, right? So now we need to work with this hidden layers. This is why, because input layer we will be feeding in the inputs, right? In the output layer we will be getting some values as your outputs or some classifications that is likely to occur. So how this machine will process your inputs and give you an output? This will be a major question mark. So for this case, we need to concentrate on the hidden layers. So in the hidden layers, you need to look into the, you need to cross check with the activation function, weights, biasing. Followed by that, you need to have cost function, gradient function, and back propagations. So I will be explaining you what is what actually that is likely to occur. So let us now concentrate on activation function. So what is activation function? I am having and I am forming a hidden layer, right? So in hidden layers, I am having a number of neurons. So in the neurons, I need to pass in some information, and my neurons need to perform and analyze your inputs, and it need to give you some output, right? So this is the case. It will be getting worked based on your inputs. So now I need to have some process in my hidden layers. There comes the activation function. You are having nearly 4 to 5 of the activation functions, that is, you will be having common sigmoid, linear, Relu, TanH. These are called as activation functions. So these will be used for your uh, what to say, will be, if you are working with the classification models, you will be using these type of activation functions, right? So if I am going to classify my inputs and predict an output as 0 or 1s, if I am working with this 0 or 1 cases, I will be using these activation functions, that is sigmoid, Relu, TanH, and linear one. So if I am having a multiple layer of classifications, that is multiple classifications need to be done, I will be going for other type of layers, that is softmax, gradient boost, and we will be having a heuristic algorithms also, right? So now let us look into the activation functions for your classification models. That is, you are having only 0 or 1 cases. So in this case, this is my mathematical model, that is z is equal to wx plus b. So where is x is called as an input data, w is called as weights, and b is called as biasing. So why we need to concentrate over this biasing parameter? This is a major question right? So I will be explaining you that if I am having my input as 0, if my input value is a 0, whatever the weights I have assigned, it will be a 0 1, because we will be multiplying your inputs with weights and your value gets 0. So you can't get a 0 value at your activation function. So in this case, you need to have a biasing parameter, that is, you need to bias to get your output from the activation function. Therefore, we will be having a parameter named biasing in this neural networks for applying it to your activation function, where you will be getting your value as 1 in minimum. You will be defining your biasing function based on your application. Commonly, we would prefer to have your biasing value as 1. So if you apply in this formula, that is z is equal to wx plus b, this is the mathematical model. So if you apply here, in the single iteration, I will be getting my biasing value as minimum value as 1. In this case, my z value will be 1 if my input value is 0. So if I increase my biasing value, as well as if my input value gets increased, my output values, that is my z parameters, will get increased. So this is the plot for a sigmoid function, that is, in the starting from 0 to 1, we will be considering your outputs, right? That will be coming out from your activation layer, that is hidden layers, as your output, right? Either it will be a 0 or it will be a 1. If you are having your negative values, it will be 0 as an output, or if you are having an 1 in your output, then your values will be a positive one, right? So this is the common terminologies which we are working. So from 0 to 1, this will be my plot. So this is the activation function, that is the sigmoid activation function, and this is the working mechanism of this activation function. So now let us switch into next activation function, that is hyperbolic tangent. So at the top I have listed you the f of x formula, that is first order formula for this sigmoid function, that is f of x is equal to 1 by 1 plus e power minus x, where in the x case you will be applying your inputs and you will be getting and you will be substituting in this formula and you will be getting outputs, right? So your outputs will be multiplied with your weights and it will be added with your bias parameters and you will be getting your z parameter, that is your output value. So followed by that, now let us concentrate over hyperbolic tangent, that is TanH function. So if I am dealing with my outputs, so my output range is from -1 to 1. In this case, I can have hyperbolic tangent as my activation function. So I am feeding in my data. So I am getting some negative values. So I need to assign my negative value to a layer, that is hidden layer. In this case, I can have my TanH as my activation function. So what will this do? What will occur here is that you will be giving your input data, it will be multiplied, and if your value is -1, you will be getting -1 as your output and it will be keep on increasing, and if your value is a +1, you will be getting your value 1 as your output, right? This in this x-axis says that your input values and y-axis says that your output values. So this is the logic that is behind your hyperbolic tangent. So in this right hand side you can see the formula for it, cos x and sin x. After that you will be getting TanH, right? TanH is equal to sin h of x by cos h of x, right? So this is your TanH formula. So you can get your outputs based on this. So this is the hyperbolic tangent. So if I need to have my value ranges from -1 to 1, I can go for a hyperbolic tangent. So next to that, you are having an activation function named Relu. This is called as rectified linear unit. So this will be starting from 0. This is actually a relatively simple function. It will be starting from 0. We will be seeing a step function, right? Step function or impulse one in our normal signal processings. So this will be a rise peak if your value is above 0. So my function will get activated when my input value is above 0. So this is the case for the Relu. In this neural networks, for activation functions, they will be preferring TanH or Relu models. Most case they will be using the Relu models. This is why, because they need to have your input values and they need to have your fast output as a faster one. That is, your performance should be a better one when comparing your activation functions. That's why they will be concentrating over the Relu activation function. So next to that, I have activated my network with the help of your Relu model, Relu activation function or TanH. So I have activated my neural network, that is my neurons, which is in a hidden layer. After that, I need to evaluate the performance of that layer, right? So it will be predicting you or it will be giving some outputs. So I need to evaluate that neuron, the particular neuron or the particular layers. So here we will be applying some cost functions. So this cost functions will help you in evaluating the performance of your neurons. How your neuron is performing with respect to your input and how it is predicting. So this helps in evaluating. So let us see what are all the parameters that we will be using here, that is the variables which we will be using. We will be using y to represent your true value and a to represent your neurons prediction. What is like actually is that if I am giving some input to my neuron, I will be defining my activation function, right? Either it's a TanH or Relu or some other sigmoid, right? So if my input is fed to my neuron, so it gets activated based on your weights and biasing parameters. So it will be giving some response to it, right? So your response will be calculated. So that will be taken as your A values. So why we will be having your true values, right? So true values in the sense you will be having your theoretical approach that if I work with this function, that is if I work with the TanH or Relu activation function, I will be getting this output. So this will be your theoretical calculation. You can name it as y variable. So your machine's prediction can be labeled in as a values, that is a variable. So your quadratic cost will work accordingly, that you will be having a formula as c. Mathematical derivation for your quadratic cost is that c is equal to summation of y minus a the whole square divided by n. This will be your mathematical formula. So here we are applying your quadratic cost as your cost function, where your c value will be calculated and your errors will be calculated. So with the help of your cost function, you are going to calculate your errors, that is the difference between your normal values, true values and your predicted values. This will be your errors, right? So if you are applying this cost function, that is the quadratic cost, you will be having large errors. This is why, because you are going to square your data. So this is a drawback of your neural network, that is unfortunately it will reduce your learning speed of your networks. So that they have preferred another cost function, that is they have gone for cross entropy as a cost function. So this cross entropy has a faster learning rate, that is your neurons will get activated and based on your values your error loss will be calculated. So your neurons gets learned based on your error loss. Okay, so this is where we are using the cost function. Cost function is to calculate the error values. that is the prediction of your models, that is the neural networks and neurons performance can be calculated with the help of this cost function, right? So next to that, we need to concentrate how we need to learn your machine, right? So we are having the activation function, that is you are going to activate your neurons, followed by that you are evaluating your neurons with the help of cost function. Next to that, I need to make my neurons to learn with the help of my input data, right? This is the objective of your neural network. So for this, we need to look into the parameter named gradient descent. So I'll be explaining you what is gradient descent. Next to that, you will be calculating the gradient descent values, and after that, you will be switching into the back propagation methods. So I will be explaining you what is a gradient descent with the help of an example. So gradient descent is nothing but if you are applying some algorithm, I need to have some shortcuts to proceed to my output, right? And this is normally a human tendency to have these shortcuts. So in similar fashion, your algorithms can also have some shortcut ways, that is the minimum possibility way to approach to a function. So you can call it as an optimization algorithms. So gradient descent is generally an optimization algorithm which will optimize your functions, that is it will be finding the minimum value of your function so that it can perform easily, right? So it can reach its output or target easily. For this we are applying this gradient descent. So this is a being an optimization algorithm. I can explain you this with an example, right? So now I am in a mountain. So my mountain is fully covered with a fog. So in this case, I need to get downhill. From top, I need to get to my downhill. For this, I am just walking in the mountains. So due to this fog, I am not sure what is the visibility that is opposite to me. So I am getting a visibility error. So in this case, gradient descent is that it will be finding the minimum path that is nearer to me. That is, I am going to walk in my visibility. What is the way that is seen by me, that will be taken into consideration, and I will be checking with the steepness of the hills, that is either it is going downhill or uphill. I need to check with the steepness for getting down from the mountain, right? So downhill will be concentrating with the steepness of downness. So you will be taking the downness values, and I'll be walking through the downness values, that is steep down. So if I'm walking further and further, my visibility gets poorer. So after this, I am taking a stick as my instrument. So with the help of the stick, I am getting down. How I am finding my way is that I am going to place my stick in a way that is visible to me and checking whether my way is getting downhill or not. So with this, I am checking my downhill parameters. So your downhill may have large holes where you can get struck off, right? So I need to check with whether it's a hole or not in this case. So if it is not a hole, then it is getting downhill, means I can go and proceed in this way. So after I am looking and looking with my possibility distance, I am getting downhill. From the top of the mountain, I am getting to a downhill, right? So irrespective of your fog, that is, it is surrounded by fog. So this is my example. In this case, I am called as algorithm. If you are considering this with a neural network, I am called as algorithm. So this fog is called as your noise or your parameters, neurons that is present, right? So this path finding, that is finding my minimum values, that is my nearer path with help of the stick, is called as gradient descent. That is the minimum value we are finding, not the maximum one. So this is the gradient descent, that is I am finding my minimum paths to get down from the hill. So I am applying my gradient descent and finding the minimum path, as well as the steepness of this hill is called as your slope function. This is nothing but if you are having some function, you will be getting some error due to cost function, right? So I will be taking the slope values of that cost function, that is the error values. I will be taking the slope for the error values and I will be getting the minimum values out of it. Followed by that, I have used an instrument, that is I have used a stick to find the way, right? So the stick is called as my differentiation function. I think so this will be clear enough. So this is the gradient descent. So the stick is called as your differentiation function, right? In the gradient descent, you will be using your first order differentiation equations. For the optimization process, you will be using your first order differentiation and you will be getting the optimized outputs. And you will be finding your minimum values out of it. So now I have found the activation function, what is the activation function and what will be my cost function. Followed by that, I have checked what is my gradient descent for my network. So now your machine has been processing, that is it is making its work properly. Now I need to recheck my values again and again, whether it is functioning properly or not, and I need to adjust my weights, that is if I get an error value higher in a higher rate at my first iteration, I need to adjust my output, right, of the neural network, that is the neurons. For this function, I need to optimize my weights. So back propagation comes into picture. What is back propagation actually? It will eliminate or reduce your errors by adjusting your weight parameters. If you have adjusted your weight parameters, your activation function will give you a better result, right? So based with the help of this better result, you can have your error value in less. If I am saying a network as a best network, that is if my developed a model, that is I have developed a neural network, I am justifying that my network is a best one, I need to have some parameters to for justification, right? For my justification, I need to consider the error loss and the accuracy of the model. So I need to have minimal error loss and the best accuracy. Followed by that, you need to have a validation accuracy in higher rate. So this will define that you are having a best neural network and your network is ready to process and function. Now we have covered the basics of a neural network. What is a neural network? What are all the layers that are present in the neural network? That is input layer, hidden layer and output layers. And we have concentrated what is hidden layer, that is the connection, intermediate connection between your input layers and output layers. Followed by that, you have checked with the parameters of the neurons, that is you are having activation function, cost function, gradient descent, as well as you are checking with the back propagation models. So this is the basic and building block of a neuron and neural networks. So in the upcoming scenarios, they have developed n number of neural network architectures. That is, they have gone for convolution neural networks, unsupervised pre-trained networks, recurrent neural networks, recursive networks, deep net neural networks, and you are having a number of neural network models. So in this scenario, let us concentrate over convolution neural networks and recurrent neural networks. So what is convolution neural networks? CNN. We will be hearing this term. So for this neural networks, we are having some of the methods to approach the neural networks. That is, if I am working with a neuron, I can have these parameters and these methods to be approached before working with the neurons. So you are activated, you have activated your neurons with the activation function, and you have applied the cost function as well as gradient descent, right? This gradient descent is an optimization algorithm, that is the first order optimization. If you need to increase your optimization rate, you can go for second order optimization algorithms, that will be called as meta heuristic optimization models, where you will be having your whale optimization algorithm, bat, firefly. You will be hearing these terms if you are going for meta heuristic optimization algorithms. So those are called as second order differential optimizers. So now let us look into the methods that we can approach to an architecture, that is, after the activation function, cost function and gradient descent, we are applying back propagation, right, to a neural network. So instead of this back propagation, what are all the methods that I can apply to an architecture, that is to a neural network? So if you are having the convolution neural network, you can apply the max pooling and batch normalization, and you can have a full net model. So these are the what to say, these are the learning architectures that I can apply to my neuron and to my neural networks. So these are all the methods that you can apply to your architecture, that is, you can have your back propagation model, followed by that you can have your stochastic gradient descent, that is, your gradient descent will be continuous with respect to your time, followed by that you can have your learning rate decay, that is, you can decay your learning rate, followed by that you can have your dropout. This dropout plays a vital role in your image processing architectures, that is, you will be having huge number of hidden layers and neurons. So I need to eliminate some of the unwanted neurons that is performing, which is giving you the negative outputs. So if I am having a large neural network and a large number of neurons, I will be having some of the layers that is performing well and that is not performing well, right? So I need to eliminate those layers that are not performing well. So in this case, I will be concentrating over this dropout model. This dropout model will help you in eliminating those layers that are not performing well. So with the help of this dropout, you can eliminate those layers and you can have your best performing layers, where you can have your faster learning rate and better accuracies. So followed by that, you can apply the max pooling methods, that is pooling of your layers. So I will be explaining you what is pooling actually. Pooling is nothing but you will be having some layers, that is, if you are going for an image, you will be having your values in terms of matrix, that is, I am going to concentrate in a 2D image, my value will be into height into pixel, that is length into breadth, right? So if you are saying it in a pixels, you will be saying it as 256 cross 256 or 128 cross 128, right? So next to that, I will be applying my convolution algorithm, where I need to define my kernel layers, that is, it is working on the convolution theorem, that is, you will be having convolution of your two layers and you will be forming a third layer. So third layer you will be defining it as a kernel layer. So this kernel will give you outputs in terms of the activation function which you are going to apply. That is, if I am going to apply my sigmoid function, my kernel value will be based on zeros and ones, which will be in a 2D format. So I will be explaining the architecture in detail. There you can be very familiarize what is the convolution and what is the kernel actually. So after applying those convolution models, I need to pull in my layers, that is, I need to apply my max pooling. So if I am applying my max pooling technique, I can have a pooled layer. So this layer will give you a better outputs. So followed by that, you can have your normalization methods. Batch normalization. What is called as batch? This is a major term which is used while training your neural network. That is, if I am having some input values, I need to train in my layer with the help of these data. For this, you will be using your batch. So this batch says that how far I need to split out my data set to train my machine. For example, I am having 1000 input data, right? So I need to train my machine with 10 data in an iteration. So if I am calling an iteration, at first iteration, I need to train my machine with the help of 10 data. So if I am having 1000 data, I can have 100 batches for it. Or else if I train my machine with the help of 100 data at an instance, I can have 10 batches. So your batches says that how far you are splitting your data for iterations. That is for repetitive task, how far you are splitting your data, right? So if I need to assign my batch size as a common one, I can go for this normalization technique. That is, I can normalize my batch size. Followed by that, I am having LSTMs, that is long short term memories. I will be explaining you what is an LSTM in detail. Followed by that, you are having skipgram and continuous bag of words, BOWs. So this bag of words will be used in text processing techniques. That is, if I am working with text and input strings, I can use this BOWs, bag of words, where I can process my input text. That is, if I am speaking with the help of my voice in the voice recognition models, I will be giving in some inputs and I will be having these values and I will be processing it with the help of this BOW techniques. Followed by that, you are having transfer learning. That is, if I am having my model at a present layer, I need to have the same model next to my layers. I can transfer my learning rates. That is, the learning methods can be transferred with the help of this transfer learning techniques. Now let us concentrate over convolution neural network. What is a convolution neural network? So if we are working with an image, you will be hearing this term convolution neural networks. So this convolution neural network says that it will be recognizing your image and it will be having your convolution theorem to work with, where it will be formed with the help of your layers. So basically you will be having n number of hidden layers in this. So this layers has been defined with the help of your network architecture. That is, if I am going to work with the CNN, I am having n number of architectures in the CNN. So based on your network architecture, your number of hidden layers will be defined with respect to your number of neurons. Followed by that, in this convolution neural networks, you will be using Relu and TanH as your activation functions. That is, if my input is an image which is a 256 cross 256 pixels, I can have my 256 cross 256 to 128 cross 128. That is, I need to descend my pixel rate for better learning and faster accuracies. So if I need to concentrate over an image, if I have a small segment of the image, I can concentrate in detail and I can have a better accuracy, right? So in this neural networks, if you feed in an image which consists of 256 cross 256 pixels, it will be segregated into 128 cross 128 as two layers. Followed by that, your layer size gets increased. This 128 cross 128 will be splitted into 64 cross 64. Followed by that, you will be having 32 cross 32. Finally, your array dimension gets reduced into 1D. You will be having an image in 2D format, right? 2D or 3D formats. So finally, in this CNN architecture, you will be having your output layer, that is the final hidden layer, will be in a 1D array. So in this 1D array, if you are multiplying your pixel values with the activation function, you will be getting your value ranges from -1 to 1, right? So this -1 to 1 will be taken into consideration, which will be pooled. So your two layers activation function values gets multiplied and it will be giving you a single value. So this will be taken into your third layer where your layer values keeps on going and finally you will be getting a value, right? So this is your layer architecture which I have explained you. So your layer size gets reduced here. If you see in detail, you can have a look, right? So at first you are having a 224 cross 224 into 3, right? So here I am decreasing my array format, that is array gets decreased into a 1D array where I am decreasing my pixels of height and width and increasing my aspect ratios, that is the layers gets increased where you are having 224 cross 224 into 64, followed by that you will be having 3 layers as 112 cross 112 into 128. So your 64 bit gets raised into 128 bits if you are concentrating in bits here. So what is the bits actually? So now let us see the first image. It is having 224 cross 224, right? This is your height pixel and this is your weight pixel, that is length, breadth, and this is your color format. If you are working with RGBs, you will be having 3 color codes RGB. So it will be taken as 3 and I need to have the color pixel values to be increased, right? So from 3 values I need to increase my pixel ratios to 64, followed by that I will be having 128 pixels and 256 pixel, that is the color values, right? 0 to 255 is your RGB color codings. So I will be increasing the color coding range, followed by that I will be downsampling my pixel values with the help of your convolution networks. So here you can see my convolution made with the help of Relu activation function, and your kernel is set where it will be making the convolution function, that is your convolution theorem will apply and it will be reducing your pixel size. Finally you will be having 1D image, that is 1 cross 1 into 1000. This 1000 says that how far your color range has been decreased and what is the array value that is likely to occur. So in this 1000, it will be a 1D array which consists of your RGB and color ranges in a single format. In a single line, you will be having your color ranges. So with the help of these data, your prediction model will be taken down and your prediction will occur. So this is the architecture of a VGG16 model. So here I have said you that we are having n number of architectures in CNN, right? So these are the some of the CNN models that are available. So we are having LeanNet 5. This is the one which has been started at first. Followed by that we are having AlexNet VGG16, Inception V1, Inception V3. Followed by that we will be having ResNet. So these are the evolutions of your CNN models. And next to that, you are also having advanced in layers and advanced models as darknet 18. These are the evolved models, right? So if you are very interested in working with CNN models and architectures, you can have a refer to it. We are having darknet models, darknet 18, ResNet X, XT50 and ResNet 50, fastnet, fast RCNN. These are some of the models that are available, which we have worked on, and you can also have a cross check with these models. So this is the models and this is the size of the model, and you can see the accuracy of the model and the parameters that the model can predict, right? So you'll be giving in some input data, right? So those are called as parameters. So these models, this is the accuracy and this is the parameters that a machine, that is your neural network, can process, and this is the depth of your model. So you can have a performance evaluation of the CNN models, and this is the image which is tabulated you the performance parameters. You can have a look into it. So this is the architecture of VGG16, that is the top model in our CNN architecture layers, which is giving you the better accuracy, right? It is giving about 90% of your accuracy with comparison with your size, right? So this is the previous one, and now we have better models, that is your darknet 18 will have a better accuracy, and it is around 96.4 percentage of your accuracy, and your model accuracy will be around 82.3, right? This is your darknet 18's accuracy, and you are having a better models in the upcoming CNN architectures. If you are really interested in working with the CNN models, you can have a cross view and cross check over the architectures. Next to that, let us see what is a recurrent neural network, right? So I have covered what is CNN in deep learning models. We have CNN, RNN, and recursive neural networks. I have covered what is CNN, right? That is the convolution neural networks, which we will be working for images. Next to that, we are having RNN, recurrent neural networks. So basically, this will be working for text data as well as the string data. That is, if you are having your data in terms of values and strings, you can have these models. So what is recurrent neural network? So this is the one which we will be calling it as a feedback neural networks. So if you are giving an input and you are processing your data with the help of your layers, if you are feedbacking the loop again, that is you are making some iterations, you will be having this recurrent neural networks. So while working with these recurrent neural networks, you need to concentrate over the epochs and batch sizes. So this is basically for every neural networks, every deep learning models, that is the epochs and batch sizes, you need to concentrate. But in specific, you need to be very keen and strong while working within the recurrent neural networks. That is how far my epochs, that is the how far my iterations are going to occur, and how far I going to split my data into a size. That is how far I am going to split my batches. So iterations, why we are concentrating over the epochs is that at first time your weights will be randomly assigned in your neural networks, right? This is the basic logic. So after assigning your weights by your network, it will be giving some value. So when we are calculating your cost function, your error value will be higher enough at the first instance. So if I need to have the better accuracy and less error, that is my error loss needs to be minimized, I need to iterate my loop again and again so that my machine will get trained and it will be producing you the less errors and less error values, and your accuracy will get increased and it will be higher enough, right? For this, you need to iterate your loop again and again. So thereby your weights get assigned randomly and you can have your outputs, that is your accuracy, in a higher fashion. For this purpose, you need to have your epochs and bias size, right? So now let us see the recurrent neural networks. In the recurrent neural networks, you are having n number of recurrent neural networks. That is, you are having time forecasting, word to vector, recurrent neural networks like time series forecasting networks, and word to vector neural networks, NLP for NLP prediction neural networks. In this case, we are going to concentrate over time series forecasting. So let me explain what is time series forecasting. So if we look into the stock market, we will be predicting, right? With the help of your previous data, we will be making a forecast. That is, if my shares are in this range, it is likely to occur. That is, it will be a downfall or appraisal of your shares, right? So you will be making some forecast in your stock market, as well as if you are going and looking into the weather forecast, you will be predicting that today your climate will be in this range, your your climate will be cloudy or dusky, or it will be sunshine. So you can have your rain today, like that. You will be having some forecast of your weather, right? So these forecast will be depend upon time. So we are calling it as time series forecasting. So in the time series forecasting, we are having some steps. That is, we are having some 5 steps. That is, you are having univariant steps, multivariant steps, multi-step, multivariant, multi-step, as well as your classification step. So I have listed you what is univariant step actually. That is, if you are having a single step, that is called as single series steps. You will be calling it as a univariant step. Or if you are having a multivariant, that is multi related observations over a time, you are observing over a time in a particular duration. I am taking my duration as 11 to 12, and in this 11 to 12 I am having my observation. So this is called as multivariant. If I am having my prediction over a series of time, that is, I am predicting my climate for 11 to 12, followed by that I am predicting for 6 to 7, or else you can have in a such a manner that I am predicting my climate for a period of month or an year. So we will be taking this as a series, right? So series of times, you will be calling it as a multi-series. So in the multivariate, multi-step, you will be taking the series as well as your time parameters. So you will be taking the year, you will be taking months, and you will be calculating your forecasting values with respect to your times. So here comes your multivariate multi-step function. And next to that, you are having the classification model. So I am going to predict something. That is, as we discussed in your earlier example, that is, if you are going for a classification or regression model, I need to predict my temperature, either it will be hot or cold. This is our example, right? So in this example, you need to have multivariate multi-step forecasting followed by the classification model. So you will be predicting either it will be hot or cold. How you can predict these conditions? Based on your previous data, right? Based on your available data, you need to make the predictions. For the prediction models, you are having some of the algorithms. That is, you are having MLPs, multi-layer perceptrons. Followed by that, you are having LSTMs, long short-term memories, GRUs, graded recurrent units, and you are having hybrid models. That is, you can combine your LSTM and MLPs like that, right? So you can have your combination of algorithms to predict for the time series forecasting applications, right? Now let us look into LSTM. What is LSTM network actually? So apart from the normal neural networks, this is the special neural networks which is having a memory. That is, I need to make the forecast application, right? I need to predict something which is happening in the future with the help of my time series data. So I need to store my data in my memories. So thereby I can have the forecast application in a proper way. So for this forecasting application, we are having a special model as LSTM, long short term memories. It will be called as long short term memories. Here you will be having 4 cells, that is input gates, that is the input layers, we will be calling it as input gates, and output layers. If you are having some outputs, you will be having the output gates. In the hidden cells, hidden layers, you need to concentrate with forget cells. That is this input gates, output gates, forget gate, cell state. These will be in your hidden layers, right? You don't consider your input layer and output layer here. You are just concentrating only the hidden layers, and in the hidden layers you will be getting the input, right? Input values will be taken from your input layers. So that is called as input gates. So after performing some of the task, some functions, you will be giving some outputs, right? Which is fed to your output layer. That is called as output gates, and you will be having the forget gate. This forget gate says that what are all the values that I need to store in my cells, that is in my memory cells, and the values which I need to eliminate. So this decision making will take place in your forget cells, followed by that cell state, in which cell your process is running and performing. You can monitor with the help of the cell state function. So in the LSTM you can use sigmoid and TanH and Relu activation functions. So with the help of your activation functions, your layer gets activated, and you will be feeding into the forget gate whether I need to store my data or not. If I need to store my data in my cells, that is, if I need to have my data in a memory, it will be stored, or else it will be processed to the next step, right? So this is the procedure and working mechanism of LSTM. Now let us look into the coding part. So we have explained you theoretically what is what and what is likely to occur and what is happening. That is how to mathematically model your activation function, your cost function, your gradient descent, and your neural networks. So you have covered the concepts in mathematical way. Now let us look into the coding part, how you need to code these layers and these functions, right? So for this we have taken the Python language, and I am going to work with the Google Colabs and Spider IDE or Jupyter IDEs, right? So I will be concentrating with Jupyter IDE. So let me show you the coding part. I think so my window is visible, right? Okay, fine. So this is the coding part for a basic neural network. At first half, we have defined the neural networks, right? Here we have called the input layers, the weights, followed by that you will be defining your outputs, right? Next to that, you will be assigning your activation functions in these layers. So if you are working with a feed forward network, here we are calling with the sigmoid function, right? So here we are working with sigmoid function and we have displayed it, and followed by that you will be having the back propagation models. This is the thing which we also have displayed, and followed by that we have assigned weights here. You can see here, this is the logic in coding manner which we need to define the layers. So I will be showing you the simulation of this coding, that how my window has been performed and how it has been worked on. So my windows, I think so my window is visible to everyone. So now let us look the process and the function of your activation function or your layers, right? I think so this coding will be easier and clear to you. So here we have called for an activation function, right? So I have an array of data, that is I am having my data set to be generated by myself, and I have generated my data. So I have placeholders. Placeholders is nothing but your, if you are working with the TensorFlow, you will be having placeholders. So here I have called the activation function, right? I have called the sigmoid activation function with respect to your coding part. Here I have defined the sigmoid function, how it need to process and function. So I have given you the samples, that is my data will be starting from -10 to 10, and I have 100 samples. So, and I will be returning some outputs. So this is how your sigmoid function works, and it's giving you the output ranges from 0 to 0 1, right? You can have a visualization of your sigmoid function in a graphical manner, that my input value is ranging from -10 to 10, and it's a 100 100 spacing values, that is I have 100 samples over it. So I am ranging my output ranges based on my activation function, that is I am having my sigmoid, so that my output has been ranged from 0 to 1. So this is my graphical presentation of my sigmoid function. So in this way you can code your sigmoid function, that is you can have your coding for your activation functions. Next I will be showing you how to define your layers, that is the hidden layers in your neural networks, right? So now let us look into this coding part again. So this is the basic coding for a data scientist to work on with the help of the neural networks and layers. So here we have taken the input parameters, that is we will be taking a data set, we will be working with the data set, we will be importing our layers, hidden layers, and we will be working on it. So for working with neural networks, your Python language has some of the model packages that you can work. So the model packages are called as, I will be naming you some of the model packages that are available. You are having TensorFlow. This has been launched by Google, where you can work with your neural networks, TensorFlow. Then you are having MXNet, MXNet, right? So this is one of the packages that is available in Python, where you can import your MXNet and you can work with the neural networks. Next to that, you are having Cafe and PyTorch. This is also a deep learning neural network framework, that is the model which you can code and develop. So these are nothing but the software providers, those who have provided the models for your neural networks, right? So next to that, you are having Cafe 2 models. Okay, so these are some of the packages and tools that are available in your Python language, where you can import your neural network layers, your functions, and you can work. Basically these TensorFlows, MXNet and Cafe 2 or your PyTorch will have your activation function, uh, layer functions as a packages. So this is the advantage of Python, right? You will be having your functions in terms of packages. So if I need to work with the TensorFlow, I can import this this TensorFlow model, and I can import my packages for activation function, defining your neural networks and splitting off your data, right? So I can import those packages and I can work with, right? So let us see the coding part, how we are working with. At first part, this is the neural network, basic neural network coding, where we have imported a data set and we have processed it, right? So from Google, I am working with Google Colab. So I need to define a function to get my data set from my local machine. That is, I need to get my data set from my computer. For this, I need to import these libraries from Google Colab. I need to import files. So after defining this, you are importing your files, and in this thing, you are calling numpy and keras, right? So let me explain what is keras actually. So I have explained you earlier, in Python language there are some of the backend frameworks that is available, that has been provided, right? Like TensorFlow, MXNet, Cafe2, PyTorch. These are the backend processing libraries that are provided. In this one I have imported TensorFlow, right? So TensorFlow is a backend one and Keras is a front end one. With the help of Keras, I can define my model. What is the model that I am going to import and work with, and followed by that I can define my activation functions with the help of this Keras. So this Keras is a front end and TensorFlow is a back end for your deep learning model developments. Okay. So followed by that I have imported my data set. That is, I am going to work with PIMA datasets. This PIMA dataset is a dataset which is working in a classification models that it will be saying you whether a patient is having diabetes or not. So with the help of the input parameters, with the help of the input data, it will be having a segregation of classes that whether a patient is having diabetes or not. So I am going to work with a classification model. So I am very keen in what is the type of model I am going to work. So if I am going to work with classification model, obviously I will be going for supervised learning. So in supervised learning, I will be working with classification model. So I am importing my data set with the help of this syntax. Data set is equal to load txt, x is equal to delimiter is of comma, right? This delimiter splits your data set. That is, I am having nearly 8 feature values in my data. So I will be splitting my values with the help of this delimiter format. So here I have splitted my data into inputs and outputs. This is why, because I am working with supervised learning, right? So in supervised learning I will be obviously having inputs and outputs. So I need to feed in my features, that is input parameters as x and your output parameters as y. So this is the logic which you need to be very strong while working with these models. So input parameters will be in x and output parameters in y. So this can be explained you with a basic mathematical function y is equal to mx plus b, right? So this is the logic and this is the function, and which I have explained to you earlier, right? For activating a neural network, you will be defining your activation function, right? That is equal to z is equal to wx plus b. So x will be your input. So similarly, this is the input for your neural network to get activated. After that, I am getting my input values and I need to define my hidden layers. For defining my hidden layers, I have called my sequential model. Why we have gone for sequential model is that I'll be explaining you the difference. If I am working with multiple layers, that is multiple inputs, right? I'm having large number of inputs. Nearly I am having around 8 inputs. So I need to work with multiple layers. For this, I can't stick to sigmoid, TanH or Relu models. So that I need to define multiple layers at first, that is multiple number of hidden neurons. Next to that, I will be defining each and every single hidden layers. Okay, so this multiple model is equal to sequential is a set of package which consists of 3 hidden layers or number of hidden layers based on the user convenience. So in this sequential model, now I am concentrating over first layer. In the first layer, it will be getting 8 inputs. So I can have 12 number of layers, that is your hidden layer should be greater than the number of input values that you are obtaining. So this is the logic, hidden neurons. So here you are having 3 hidden layers, and in a first hidden layers you are having 12 hidden neurons. The hidden neurons should be greater than the number of inputs. This is the logic. So I am having 12 hidden neurons, and I am going to activate this hidden layer with the help of Relu function, where my neurons gets activated and it will be starting to perform its functions. Next to that, after performing in first layer, your data goes to the second layer, which consists of 8 number of hidden neurons. So next to that, it will be going to your last one, that is it will be going to sigmoid function. Sigmoid function says that whether my case is 0 or 1, right? Your output ranges from 0 to 1. Why we have chosen the sigmoid function is that in your data set you are having outputs, right? That is your labels. My labels will be in the range of 0 to 1. Either if I am a normal patient, that if I don't have diabetes, I will be considered as 0, or else if I have diabetes, I will be considered as 1. So your output ranges from 0 to 1. Here your activation function, that is sigmoid, its output ranges from 0 to 1. That's why in the last hidden layer, you need to select sigmoid as your activation function. So this is how you need to select your activation function based on your inputs and outputs. So next to do that, I am going to compile my model. That is, I am going to run my model where your model gets trained, right? So I am going to apply binary cross entropy, which we have discussed earlier, right? The cost function to evaluate your loss and errors. For this, I am going to apply your cross entropy for calculating the errors, and I am going to optimize my models, right? There we have seen gradient descent for optimization. Here we have used Adagrad optimizers. So these are the second order differential optimizers which I have discussed earlier, right? So the first order, if you are working with first order, you can go for gradient descent optimizer, or if you are working with second order iterations. Why we are going for second order iteration is that your inputs and hidden layers are numbers are higher one, right? You are having higher number of hidden neurons and higher number of hidden layers. For this function, I need to have the second order optimizer and optimization techniques. For this, I am going to apply my Adam optimizer. This is a second order optimizer. So I have applied my optimizer. Followed by that, I need to have some validation outputs, right? If my network is functioning, I need to have some values as an output. So I need to calculate my accuracy of my model. So this is the procedure, and I have calculated the accuracy of my layer. That is, if I am iterating at the first instance, what is my accuracy? If I am iterating my model at the second instance, what is my accuracy? This is how you need to calculate your accuracy of your model. Followed by that, you will be having your fit. This fit says that you are training your model with the help of your data, right? So with the help of x and y's, you are training your model. This is how your machine gets trained. So I have defined epochs as 150. Epochs is nothing but your iterations, number of iterations you are going to make. So batch size as 10. So in the 10 in the sense, I have 150 iterations. So I have defined my batch size of 10. That is, if I am having my data to be 1000 and it will be taking the 100 iterations, so I will be having extra iterations as well, right? So this is why, because I need to have better accuracies. For this, I will be having additionally 50 iterations, right? 50 epochs in addition. So I have defined my batch size. So next to do that, let us start in predicting the accuracies, right? If I run this code, I can define the accuracy. How far your accuracy has been defined is that I am loading my dataset, that is the PIMA dataset. How this accuracy has been done is that based on the input data, your machine gets trained, right? Using your models, deep learning models and networks, you are training your machine, right? After this, your machine gets trained. Now I need to give in my input parameters. I will be feeding some test inputs to check what is the prediction that is likely to occur with the help of my trained data. This is that I will be having test inputs and I will be testing my machine and trained, right? Based on your trained one, you will be applying your test input and you will be testing your machine. So based on the learning algorithm and learning models which the machine has trained, it will be having some knowledge of testing. So if I give some input, I can get some output, right? This is the knowledge which you have fed in, which you have trained your machine. So finally, if I give some inputs for test inputs, that is the feature ones, your machine will make some predictions, right? How far your machine prediction and your true values and your predicted values are accurate that will be considered in your accuracy parameter. So here you can check, right? My accuracy is about 75.78%. So I need to improve my accuracy. Why I have obtained this less accuracy is that I didn't have a valid data, that is I didn't have a pre-processing of my data, that is removing my unwanted data and making a valid data. Followed by that I didn't touch my input layers and input neurons. If your accuracy is less, you need to work with the hidden layers and you need to improve the hidden neurons, as well as you need to change your activation functions. Next to that, you need to concentrate over the layers. If you do this, your accuracy will get increased and you will be getting the better accuracies. Then you will be getting your accuracies around 95 or 100, right? So due to the less accuracy, I can have the deviations in my predicted model. In this test case, I have fed in my input data. These are the features, and these features will correspond to abnormal patient. So these features are a data of an abnormal patient. So this is your true value and expected one, right? Sorry, this is your predicted value which your machine has predicted based on your input data, and expected one is your true value. So if you are giving this input features, your expected output should be 1. That is the supervised learning algorithms models concept, right? So I need to be very keen with my output, that is my expected value will be 1. So based on my training and testing of data, my machine is predicting as 1. Here my predicting model is correct. So what the machine has predicted is correct, right? So this is how a data scientist should work with a data set, right? So if I should feed in my input, this is how you will be getting the outputs. Next to that, you can have the comparison of your image data set. Here we have worked with MNIST data set, which is an image data set. So this MNIST is a standard data set which has been provided by Keras and TensorFlow. They have given for numbers, fashion models, right? So this is the one which comes under unsupervised learning models. So here I will be having a data set. I need to segregate the classes, right? So this comes under unsupervised learning model. So this will take some time. So I have made a run over this algorithm. So you can see here the number of neurons which we have defined within a hidden layer, right? So your batch size will be 64, epochs will be 20, and you can see here I'm calling my sequential model as sequential model, and I'm defining number of layers. So these are my number of layers. At first step I am calling convolution 2D, where my input number of neurons will be 32 and kernel size will be 3 cross 3. So my activation function will be linear padding. Padding is nothing but this is an extra function. Whether my kernel function needs to be same or not, this is defined by padding. So I can have my padding value. So finally, your dropout layer, that is you will be having your dropout layer and you will be saving your model. So these are the procedures that we need to concentrate while working with the image datasets. That is we will be defining your models and we will be having the data. So finally, if you run this model, it will take 20 epochs and you are having about 48,000 data set that has been provided by MNIST. So this is the classification. So I have 10 classes, that is starting from shoe to bag, I have nearly 10 classes. So this is the input which I have filtered in. So your machine has been predicted, that is it has been clustered and grouped how much data has been to a specific class. So this is the predicted model of your unsupervised learning, that is clustering algorithm takes place. and you have defined the clusters. So this is how in coding part you need to concentrate while working with the neural networks. Either you are working with the TensorFlow or MNIST or Caffe or PyTorch or not. We have worked with the TensorFlow, and this is the logic and coding part. Now let me conclude the session by showing our models that we have developed. So these are the some of the products which we have developed in deep learning. That is, we have made a chaotic encryption algorithm for your deep learning models. So this is the industry project that if you are working with encryption of data, that is if you are working with security algorithms, that is I need to have my input data and I need to feed in my data, right? This is plays a major role if you are working with cloud network analysis, security algorithms, hash creations, followed by that data transmission over your network, long range networks. And if you are working with the banking sector or any other privatized sector where the data need to be secured, you need to have a development of your model, right? So we have developed a chaotic deep learning model where we have obtained a chaos equation over the deep learning networks, right? So if you are I will be sharing my contact details. So if you are really interested, you can have your doubts. So next product is that we have developed NLP feed forward network, that is multi-layer perceptron feed forward networks. Next we have developed CVAs, that is in this COVID-19 we have worked with the image data sets, and we have formulated a new algorithm named coronavirus algorithm CVA. So this model predicts you the normal patient from abnormal patient with the help of your data sets. So we have taken the X-ray images and we have developed an algorithm and we have formulated this. So we have submitted this to the government and the evaluation is under process. Next to this, we have made a guide analysis method, that is with the help of the human physical movements, we can make an online physiotherapy test and we can predict what is the type of disease that a person is having. Whether he is having paralysis of his hands, cerebral paralysis, like this, right? The disease which is mean with your physical appearance. So these can be made with the help of your gait analysis model. So next to that, we have developed n number of hybrid neural networks. That is, we have combined machine learning along with deep learning along with deep learning, ELM along with some other layer models. So we have developed n number of hybrid neural network models. Finally, we have developed word to vector hybridization. That is, if you are working with word to vector models, we have developed hybrid models for those things. That is a text analysis process, right? If I am working with text and if I am giving input as a text, we have developed some hybrid models for this word process. So I would like to conclude my session, and if you have any queries, you can have it in discussion forum. So if you have queries, you can have it in the discussion forum, or else we can conclude our session. Let me wait for 5 more minutes. So guys, if you are in need of this PPT for this session and other details, you can contact us. I have given you my WhatsApp as well as my Gmail. You can contact me at any time and I will be sharing you the PPT, as well as you can contact the Grow 90 team. They will also provide you the data that is handled in the today's session. For the CVA image dataset, we have taken the images. Okay, guys, I would like to conclude my session. Thank you all once again for participating in this live webinar on concentrate on data science with neural networks. And I would like to thank Grow90 team for selecting me as a resource person. And I would like to specially thank the deep learning AI team community, which is a global forum, for recognizing me to have a deliberate lecture over the deep learning concepts. Thank you all once again, and thank you so much.